Welcome to homework.
All right, welcome back. We're now on to chapter 13, and it's problem 76. And we're looking at what is the freezing point. So we're solving specifically for the freezing point of an aqueous solution that boils at 105 degrees Celsius. So let's break down what they're giving us. So we need to find out what the boiling point is, and they gave us, or freezing point, and they gave us the boiling point. Well, we don't have any equation in our repertoire that we've learned so far that'll help us out. But what we do know specifically is aqueous solution always means water. And we are able to look up some information on water. We do know that the freezing point, or the Kf value, freezing, is always going to be 1.86 degrees Celsius to molality. And that's specifically for freezing. And then also looking up in our textbook, if we look back in chapter 13, we know the boiling. The boiling point for water is 100 degrees Celsius, and specifically, that is going to be 0.51 degrees Celsius per molality. And the reason it isn't just exactly 1 is that water is K2O. So molality is how many moles per kilograms. So we're dealing with a different structure than just Celsius. And we're given a boiling point here. So what formula have we learned about in chapter 13 that'll help us with boiling point? So if we go back to what we've learned, we were giving a boiling point elevation, which is the change in temperature is equal to Kb times molality times I, and that I is Van Hoff's factor. So that's how many ions a molecule will break down into. We weren't given any information here whatsoever that's going to help us solve for molality or our Van Hoff's factor. But what we were given was Kb, and that was our 0.51 degrees Celsius to molality. And we were given the change of temperature. So we know that we have temperature of the solution, which is right here, 1.05 Celsius. So 105 degrees Celsius is our temperature of solution, and we know that water boils at 100 degrees Celsius. So this problem required that we understood a lot of what happened in chapter 1, the colligative properties of just water by itself. And that's going to be times m, our molality, times I. So we can solve for m and I. And let's do that real fast. We know that 105 minus 100 is 5. So that's crossed out for us, and that's equal to 0.51 degrees Celsius molality times m times I. So let's look at that. Oops, that was an I. Just kidding. All right, so to get this by itself, we divide both sides by 0.51 and divide this by 0.51. We put it in our calculator, and let's find out what we get. We get 5 divided by 0.51. So we know 9.81 is equal to m times I. And that hasn't given us anything specific because we still need to get to our freezing point. So let's look at our freezing point. What colligative property formula have we looked at in this part of the chapter 13, that deals with freezing point? The only thing we've seen is that a change in temperature is equal to negative Kf times m times I. And we've now solved for m and I. So our molality and our Van Hoff's factor. And we know our Kf because it's of water. And our change of temperature, if we're at freezing point, what temperature do we have for our pure water? It's always at 0 degrees Celsius. So let's look at our change of temperature. So we know if we have pure water minus some number, our freezing point, it's going to equal negative Kf, which is 1.86 degrees Celsius to molality. Oh. And over here, Mi is 9.81. That's perfect. So let's put that together in our calculator right here. We're going to have negative 1.86 times 9.81. That's going to give us negative 18.246. Because of this, we're going to round up to 5 degrees Celsius. Perfect. So we know the change in temperature is our temperature of solution minus the temperature of our solvent. And we're actually solving for, let's see, temperature of our solution minus the temperature of our solvent. So freezing point of our aqueous solution. So we're solving for the entire solution. And we know our solvent is pure water. So T solution minus degrees Celsius, 0 degrees Celsius, because that's the temperature of pure water freezing. And let's solve for that. So T of our solution equals 18.25 degrees Celsius plus 0 degrees Celsius, which is perfect. Whenever asked for the freezing point when given the boiling point, or vice versa, you have to use both equations and use the substitution method. Excellent, good job.